to ensure that all the people turn up. Chandra, I will ping you through WhatsApp.
Yeah. Okay, I think we are live.
Yes. Okay, so I think this is the time to start. Good afternoon, everyone. Hope you all are doing well in this current difficult time. On behalf of organizing committee and core committee, I would like to welcome you all for our the second mid-year meeting. Unfortunately, again in the online mode, but still we are happy. Hope we will have our next annual GBM in offline mode. Regarding this event, as you all already aware of, the theme of this event is Free the Science, which is very important considering the current time, and we all want to discuss on this very important area. During next 3 days, starting from now, we will have total 5 sessions in this event, and 2 of them will be technical. And as we know that the topic of the first technical session is open science, challenges, possible solutions, and the way forward. And the session chairs will be Nishant and Utub. The second session tomorrow morning, the technical one, the title is Communicating Science, Need of Time, and the session chair will be Nishad Fatima. Then we will have our INYAS session where we will discuss our own agenda items, and all CC members will also present the progress of different areas. Then tomorrow in the evening, we will have talk by Alexandra. And on last day, which is 15th of August, we will have a special session called INYAS NYA session that we will celebrate also as Azadi Ka Amrit Mahotsav. And in that session, there will be participation of young academies from 7 countries this time. As convener, this is my duty to thank all for their contribution. I would like to thank first chair INYAS, Chandrasekhar Sharma, all CC members and organizing members for all their support, suggestions, and hard work to make this event successful. I also thank session chairs, Nishant, Kutub, and Nishad for proposing technical sessions on very relevant and needful areas. We all are grateful to all the speakers of different sessions for agreeing to discuss on these very important topics. I must also thank INYAS office, Ms. Madhvi, for her constant hard work for all kind of things which we discuss together to make this event successful. Finally, let me thank all of you, because as we know that without active participation from everyone, the event cannot be a successful event. So I really thank you all for your support, active participation in fact in all INYAS events, and I'm sure that this event will be also very successful. So with this, I would not take much time. With this, I would like to invite Chair INYAS Chandrasekhar Sharma for his inaugural talk. Chandra, over to you, please.
Thanks, Rajendra. Good afternoon, everyone. Dear friends, welcome to this second mid-year meeting of INYAS. This is our third consecutive gathering on a virtual platform. And of course, we really miss our in-person meetings and discussions. In fact, in last 18 months, we had only one core committee meeting in person in March this year in Delhi. As a virtual platform have become a new normal, from convenience to the necessity, we have no other way but to be on a screen again to inaugurate this second mid-year meeting of INYAS today. As we know that the country has witnessed a very severe second wave in the second quarter of this year, and now we are again apprehensive about the third wave. India has done significantly well in terms of vaccination. I'm sure we all are vaccinated at least a single dose till date. Amid all this, we have learned many new lessons. One such example is the science communication. we could not have realized the importance of science communication better than the current times. And this has also resulted in the reviving of old debate on the need of science for all. And that's why in the current situation, this year's INYAS media meeting is focused on the theme, Free the Science. In this media meeting, as just briefly told by Rajendra, we are going to have two technical sessions on open science and science communication today and tomorrow. There is a great line of speakers to share their views on these important topics. We also have a plan to prepare a white paper as an outcome of this meeting. We have a public lecture tomorrow evening by Alexandra Elveken, founder of Sci-Hub, who has completely changed the landscape in terms of access to the scientific publications, free to everyone. While there might be some apprehension on ethical aspects of it, but this public lecture will give us more insight about this alternative model in scientific publications. Tomorrow, we also have a general session exclusively for our members, in which core committee will present its half-yearly report and discuss the various issues of general importance to INYAS. On 15th of August, when we will mark the celebration of our 75th year of independence, as a year-long Azadi Ka Amrit Mahotsav, we shall start this Mahotsav with a special session with the 6 of our neighborhood national young academies: Nepal, Bangladesh, Sri Lanka, Thailand, Malaysia, and Indonesia. In this session, we aim to develop the new partnerships and enhance and strengthen the existing partnerships. We aim that this network of national young academies in near future catalyze the free exchange of ideas among the young scientists to help each other and enable our vision of access of science to all. With this, I am glad to formally inaugurate the second meeting of INYAS 2021, and once again welcome you all for joining. I'm sure next 3 days we shall enrich ourselves with the new thoughts, discuss new ideas, and make new friends. Thank you.
Yeah, thank you, Chandra. Thank you for very insightful discussion and the inaugural talk. Now I would like to request Nishant and Kutub to take over for the technical session 1.
Thank you, Rajendra, and thank you, Chandra, for your inaugural talk and the way we are going to meet during this entire session over the next 3 days. So as we all are aware, the first technical session is on open science. So firstly, a very warm welcome to everyone to this first technical session on open science challenges, possible solutions, and the way forward. So during this session, we have excellent speakers. And first, we would definitely go ahead with our keynote speaker, Professor Peter Murray Rust. So as rightly mentioned by Chandra and Rajendra regarding the need for open science, everyone believes that science communication should be free for all. However, the scientific community is very well aware of the challenges of scientific publications, with publish or perish being the aphorism describing the pressure to publish and the changing landscape of scientific publications. We think it is a high time for us to open this debate. And as I mentioned, we have wonderful speakers during this session. First, we have Professor Peter Murray Rust, who is a world-renowned figure advocating open science. So Professor Rust is a professor, Center for Molecular Science Informatics, Department of Chemistry, University of Cambridge. He is the group head, lead designer of chemical markup language, and is an open science activist, as I mentioned. His research interests have involved the automated analysis of data in scientific publications, creation of virtual communities like the Virtual School of Natural Sciences in the Globe-Wide Network Academy and the Semantic Web. He campaigns for open science data and is on the advisory board of the Open Knowledge International and a co-author of the Pattern Principles of Open Scientific Data. He is one of the founder members of the Blue Obelix movement in 2005, which is essentially an informal group of chemists who promote open data, open source, and open standards. So Professor Rust, during his presentation, will also take us through a short video presentation, which has been created by his students and interns, Shweta Hegre, who is from Regional Institute of Education, Mysore, and Ayush Garg, who is from Global Indian International School. So essentially a very young, talented student from Singapore. So their presentations will concentrate on creation of access to scientific knowledge and much more. So without further ado, I would like to hand over the platform to Peter. And Peter, if you are there, you may please unmute yourself.
Yes, I hope I'm unmuted. I've got my PowerPoint here. I need permission to share the screen.
Sure. So Madhavi, can you please help us?
Yes, he can share the screen. Just go to the bottom, no, share screen option.
So you will have the share screen option at the bottom of the screen, Peter.
Right. The trouble is I've got PowerPoint and I've got Zoom up at the moment. So
maybe you can just minimize the Zoom first and then try.
It's okay. I'm fine. Right. So can you see my screen now?
Yes.
Excellent. Right. So off I go. Right. Sorry?
Go to the slideshow.
Yes, I'm going to slideshow in a minute. Excellent. So we will play from start. That slideshow, okay, and off we go. So I'm delighted to be giving this keynote lecture, and I want to particularly highlight the collaboration that I've had with the NIPGR group and more recent with Geeta Yadav, and more recently with wonderful interns who've joined our program, and one cohort from INYAS last year, and hopefully in a few days another cohort, and that's very exciting indeed. So there will be this embedded presentation from Ayush and Shweta halfway through, and then I will finish up and give some pointers for the future. So off we go. My themes are collaboration, open notebook data science. So although this applies to all open science, I'll be concentrating on data science, which is taking existing data and getting new insights from it. And we're going to use open notebooks, the idea of Jean-Claude Proudly, which I'll talk about in a minute, that everything we do is on the web from the moment that we do it. No hidden knowledge, no delays, nothing. Unfortunately, there's a lot of antagonism to open, mainly from the major publishers, but also from some academics as well. And that is holding us back very severely. I'm going to talk about mining open access for open science. That's the main theme. And Ayush and Shweta have been doing this. And they're going to give their philosophies of open, and I'll be talking a little bit about what they're doing and so on. The current project is called CEV Open. You don't need to worry what that means. And it's about mining the plant literature. So most of you will know about plants. And finally, I'm going to talk about the future. So here's a bit of history. In about 8 years ago, I set up an organization called Content Mine, which believed that you could get science by mining the literature. And In 2014, my colleague Jenny Malloy from Cambridge visited Gita, there's Gita, and we had a virtual workshop all those years ago, which went very well. And as a result, Gita and I became collaborators. She was awarded a prestigious lectureship at Cambridge, the Cambridge India Joint Lectureship, and she's done that for 5 years. And here, 2 years ago, is the Tigris program in NIPGR Delhi. Here you can see Gita right in the middle, and that's a wonderful program. We had a one-day workshop where 50 people came from all over India, and we did data mining for plant science, and it was a great technical success. And as a result, we set up this program of internships. Started with 2. Here's Priya and Karina. They did a wonderful job with nothing to start with about a year ago. And that quickly then got overtaken by the coronavirus. And we believed that we had to drop everything and try and put our resources into fighting the virus. So we started a program which collected scientific knowledge about viruses to see if it could be useful for the world. And then that came to an end a year ago, at the end of the year. And this year, we've been transforming this into plant science. We call that CEV Open. You don't need to worry why. And we're at an intermediate position between the first lot of interns and the second lot of interns. So let me tell you a sad story. This is a published scientific paper. It's 40 years old, and they predicted that in West Africa, Liberia, there would be at some stage Ebola and Marburg viruses. Unfortunately, this was hidden behind a paywall, Elsevier paywall, and it is still hidden behind the paywall. And as a result, the Liberian government didn't see it, and they were very upset. They claimed that if they had seen this, they might have been able to take action before it happened. So can we stop that happening in the future? Well, the idea is that we can scan the literature for those things, and this is not a difficult technical problem. We're just looking for words like places or diseases, and can we make that available to everybody in case there are new diseases? And unfortunately, they've just told us last week that West Africa has now got the Marburg virus, exactly as that paper prophesied. So here's our first group of interns. I'm not going to be able to talk about all of them because there's too many, but they're all wonderful people. So we started by dividing this into 8 mini projects. These were mainstream things like country, disease, drug, funder, virus, and more complex ones like the role of animal hosts and non-pharmaceutical intervention. And it works by downloading the literature. Our main resource was Europe PubMed Central, which is free for everybody. Don't have to be in Europe. And we built dictionaries for annotation based on Wikidata, and we'll show you that later. So here, for example, are some of the facets: viruses, disease, drugs, country. Notice also that we have multilingual dictionaries. That's very important, and we'll come back to that later. So this is our one of our star students, Ambreen, who pioneered the use of Jupyter notebooks, and she took the results of her searches to look for the most common diseases in the literature, infectious diseases. And you can see influenza was by far the largest number of papers in the literature, you know, over 1,000. And these are the countries that they were associated with. Now, this was rather crude because we had crude technology. We're improving that this year to make this much more precise and perceptive. And here's another way of looking at it, that these are the diseases here, these are the countries, and this shows you where the co-occurrence in the papers are. And this probably reflects the countries who are working on it rather than the countries where the diseases are, but it shows the type of approach that we can take as data scientists. So again, the team that we've now got, and there are several slides here. I'm not stopping to talk about all of them, but I'll highlight Shweta and Ayush, who are going to be talking to you later. And we'll also be hearing from Chaitanya and Saga, or showing their work. Right, so what's open science? Well, open science is very, very broad. It's not the same as open access. And it's the idea that scientific work is done for everybody in public view. And one of the best known examples about 20 years ago was the Human Genome Project, where they decided that all DNA sequence database data should be put on the web as soon as it was created, the so-called Bermuda Principles. And because they did this, they were quicker and faster than the competition, which was a closed access approach from Craig Venter. And I don't think they would have won that without having this open approach. There are now many different types of open science. This is Zooniverse, which is crowdsourcing, where you can see they've had 70,000 people cataloging galaxies. You don't need to be an astronomer. All you have to be able to do is to distinguish where a galaxy starts and where it ends. That's not actually easy for machines, and they found that humans could do it better, and that you didn't have to be an astronomer. So many people who'd not done any science were actually good at cataloging galaxies. This is a practical thing. My colleague Sean Bonner woke up one day in Tokyo and found out that the nuclear reactor at Fukushima had exploded because of an earthquake. There was no data on radiation, so he and his team dropped the jobs they were doing in IT, and they built wonderful Geiger counters and put them out to the world to collect data, and they've got over 100 million data points. And here are some of the data points that I collected in England. None of them were serious, but you can see here around the nuclear reactor, the very high levels of radiation. And one of the greatest open projects is Wikimedia, and as soon as coronavirus hit, the Wikimedians set up a wiki project where they put together as much information, tools, community as they could to help in fighting the virus. And this is done without any sort of impact factors or public glory. They do it because it needs to be done. And Wikimedia is one of the great inventions of this century. I'm not going to say much about physical open science, but just to say that there are huge opportunities. I'm a member of Cambridge Makespace, and in this we have laser cutters and 3D printers, and Jenny Malloy helped to set up Bio Makespace, where you can do gene experiments, category 1. And again, you don't have to be an academic to do it. And every country has now got this, and I've just made a little map here of the Delhi ones. And if you're interested in this, I'd strongly recommend you find your local Makespace. And the potential is huge. So we took the tools that we're going to be talking about, the open virus tools, put all the papers on a disk. You can put the open scientific articles on a little hard disk like this, put it on a Raspberry Pi, put our software on the Raspberry Pi, and then you have a complete scientific literature system that, if you like, is what the modern library looks like. Unfortunately, there are people who don't like that because they have vested interests. So here's the problem. Most science is not open, and it's not open because it brings in revenue for the publishers. So if you search for social distancing on Taylor and Francis, you can do it yourself, sorry, then you'll find 500,000 papers, but only 20,000 are open. That's 5%. And other ones like most of the big publishers in many subjects vary, round about 10% is open. And that will never be open unless there's a big change. They'll never make that open to the whole world. And I call this neocolonialism from the global north. It's exploiting the global south. I was in Ghana many years ago with Kwame Nkrumah, and he came up with the idea of neocolonialism. And he said that the investment under neocolonialism increases the gap between the rich and the poor scholars of the world. We now talk about global north and global south. That's something which I think India has to make. I can't help you what you should do, but I think it's an issue you have to tackle very rapidly. You have a huge opportunity. So I call the problem the publisher academic complex, after something called the military industrial academic complex. And this is a group of organizations which is out of control. So the taxpayer and the student and the researcher put huge resources into this, academia then sends it off to publishers, pays them huge amounts of money. It now costs $12,000 to publish in Nature. And what do you get back? You basically get back glory for academia, impact factors, and that enhances your chance of getting a job in the high-ranking universities. And that is totally, in my view, unacceptable. So because of that, we're seeing knowledge paywalled. And here's my colleague, Chris Hartgerink, who also did text and data mining. He started doing it. It was legal, but when he did it, Elsevier detected it, and they told his universities to stop him doing it, and that he was a thief and called in names, and the university stopped him doing his research. And I've had that happen, and other people have had that happen. So in all of this, the reader has been forgotten. It's the reader that matters, as well as the author. And people should be publishing for readers, not for not just for authors and glory. This was highlighted by your great library scientist, Ranganathan, in the middle of last century. I paraphrased his words, but basically scientific publication is for use. It's not just for archiving, it's for use. And another of his 5 laws was save the time of the reader. And our readers want to read a paper every second, not mailing an author who might reply, not having to go through some complicated login thing, and so on, every second. And you'll see that in a minute. So why open? Well, a single word, it's better. That's the single justification for open. I couldn't have been telling you what we're doing here unless we had it as open. It's quicker, it's flexible, it's inclusive, collaborative, and you get preservation as you do it. Now, the Budapest Declaration of Open Access 20 years ago was a fantastic document and had wonderful principles that this should be access to everybody, not just academics, but any curious minds, and that it should be sharing the learning of the rich with the poor and the poor with the rich. That's the really important thing. And the North is now arrogantly saying that it doesn't care about the science which is coming from the global South. But they didn't get the implementation right. And open access has now, in my view, failed. It's failed these principles. It's become incredibly bureaucratic, complex, and very, very expensive. And it means that only rich global North universities have full play in this system. So I'm going to talk about Open Notebook Science. Now, this is a subdivision of Open Science. It was developed by Jean-Claude Bradley about 15 years ago. Unfortunately, he's died, but he was honored by President Obama for this. And the key idea is that your laboratory notebook is freely available on the web and indexed, and it's done immediately. And everybody in the world has access to that. So here's a wonderful example, open source malaria. This is last week's stuff. They've tweeted their latest synthetic compounds right there. They haven't patented them. They haven't hidden them behind paywalls. They've put them out, measured them, and told the world about them. And so you get immediate public discussion. And another wonderful project in India is open source drug discovery, where they had over 7,000 participants and spread across the country. And much of this was computational, so it was available to everybody. We followed this. Here's Shweta's notebook, and if you look at it on GitHub, you'll see that she put something up yesterday, and it was updated in real time. And anybody can read Shweta's notebook or any of our other notebooks. So I'm going to be talking about our mining strategy. We call it content mining because we can mine images as well as text. And the idea is you go to open sources or whatever material you have on your hard disk. So this is not limited to repositories. You can have it all on your hard disk if you've got legal access. You scrape it with PyGet papers. You clean it. Unfortunately, there's a lot of cleaning because it's in PDF. You annotate it with Wikidata. That's my tool, PyAmy. And then you analyze it and display it and publish it. And that's Shweta's doc analysis. And it works for any subject. It's not just plants. And we've developed it for material science and batteries, for climate, and for medicine. And you can extend it to geosciences or whatever. So this is a typical way of how we work. Here were last year's 8 interns. Each of them had their mini project, which we mentioned before. And each of those projects had tasks and milestones, which they had to take on board. And this is a traffic light, so whether they've started it, whether they've completed it. And there's no shame in not completing it, because if you have problems, somebody else will take that on and so forth. So it's truly collaborative. So now I'm going to hand over to Ayush and Shweta. Ayush is a volunteer. He joined us through a hackathon done virtually in Cambridge. He's 16 years old at school, and he's done a brilliant job in developing the code. And this code is now top quality, and it's being put on the official Python PyPy archive where anybody can get it. And Shweta is our project manager, and she's pioneering the use of data for machine learning and textual analysis. So I'm now going to hand over to them. I hope we can do it quickly. So I've actually got their presentation down here, I think. I'll open it up here. I knew there would be a small glitch somewhere or other.
Stop sharing.
I've got to stop sharing, right? That's the first thing. No, I don't have to stop sharing, do I? I forget this. I think I do.
Can you please guide Peter?
Sorry?
No, I'm just asking our office to guide you, please.
I did this all this morning.
Should be fine. Should be fine. Please take your time.
Okay, let me just open that up. I'll put it on full slide, on full share, because then it allows me to do it. Right. So can you see
The
the
scientist is motivated primarily by curiosity.
Peter,
and a
you need
desire.
to share again the
I am
screen.
Ayush Garg, the author of Pygate Papers, an
We can
open
hear
source
you.
tool for
Yeah, I'll
automated
do it.
retrieval of scientific
I'll do
literature.
it.
And today, I'm going to talk about open source for open science and my journey into becoming an open source developer. So
I've
let's
lost-
start from the beginning. What motivated me to contribute to open source in the first place? Well, my story of open source starts with the drive to help progress science and a passion for having.
Okay, the problem is that it takes over my mouse. So let me just work this out.
Sure.
Am I sharing it?
We can share it from our end also. If
Have you got the URL?
Yeah.
Yes, yes.
Okay.
So
You
Kutu,
share
can
it
you please
from
try
your
that?
Yeah, I can do that.
Yeah, perfect.
Yeah, you share it from your end and off we go. Okay.
Utub, are you sharing this?
Yeah, I'm sharing.
Yeah, okay.
Is it visible now?
Yep.
Okay,
Perfect.
yes. Yeah, so I'm running it.
The scientist is motivated primarily by curiosity and a desire for truth. I am Ayush Garg, the author of Pygate Papers, an open source tool supporting automated retrieval of scientific literature. And today, I'm going to talk about open source for open science and my journey into becoming an open source developer. So, let's start from the beginning. What motivated me to contribute to open source in the first place? Well, my story of open source starts with the drive to help progress science and a passion for having an impact on the scientific world, even if it's little. For me, science is the medium behind human progress. Every question that we start to solve leads to the creation of 10 more, and this whole move towards questions that we collectively come together and solve leads us to reach new heights of innovation. To this end, the very fundamentals of science call it to be open and inclusive. Now, one of the crucial ways to make science open and inclusive is through promotion of open access literature. And to promote practices of open access, I started developing Pygate papers, which makes getting bulk open access not only easy but also uniform across all the different repositories and data formats. Now, a question that generally arises is, who can do science and contribute to open source? Is it people wearing coats in labs? Is it scientists working in big laboratories or firms? Or can it also be 16-year-olds like me? The answer is very similar to the answer to the question, who can sing? Basically, anyone with enough motivation. There is no wrong time to start contributing. You're never too old or too young. It's all about catching that motivation and inspiration, and the rest becomes history. In this day and age, the greatest, largely untapped knowledge pool resides with the young population. Even if a small chunk of the young coding population was exposed to the open source philosophy, we'd see a huge uprise in the number of open libraries. But we all know quality is greater than quantity. This brings about the discussion, what makes good open source? So, when it comes to code that is open to all, the expandability, maintainability, and navigability of the project is crucial. Code conformance, documentation, flawless packaging, good issues, unit tests are fundamental for the propagation of code supporting open science. I also highly advise the inclusion of things like code of conduct, license, contributing, and workflows. 7 months in the development of Pygate papers and 150 commits later, I can proudly say that Pygate papers supports and promotes a large majority of these practices. Finally, I'd like to end by quoting Aaron Swartz. A piece of knowledge, unlike a piece of physical property, can be shared by large groups of people without making anyone poorer. I'd now like to pass on to Shweta, who will talk about her messages and learnings through her experience as an intern at CV Open.
Thanks so much, Ayush. I'm Shweta Enigde, and I'm currently the project manager and an intern at CV Open. Today, I'm here to share my experiences as an intern at CV Open, give you some of my messages, and reflect on my learnings. To give you a little context about myself, I'm a life science undergraduate student studying at RIE Mysore, and I joined OpenVirus about a year ago now with no coding or managing experience. To start out, in the first 3 months, I initially focused very little on the technical aspects of the project and focused more on the communication and the outreach. Cut to the present, I am now involved in coding and technical aspects of the project. I employ natural language processing and machine learning to extract ethics committees and many such entities from the scientific literature. But the point here is not to talk about the project, but to discuss the transition. How did I go from someone who had never written a single line of code to who I am now, where I do a fair bit of coding? Did the transition happen overnight? Was it smooth? Well, not really. Now let me tell you the story in between, the struggle. When I started out, I had no clue about many of these technical things like command line. I did not know how Git worked or what a command line tool was, and so on. So there were several instances where I thought I should give up, but I really wanted to make a difference in science. So thanks to the wonderful support from the team, both my mentors and co-interns, I started picking up these skills as I went on. And I kept persisting month after month. And therefore, now I am able to contribute to the project significantly. So my journey is also documented in the open. So I do go back sometimes to see how far I've gone. Of course, there's a long way to go. So the open science community has not only helped me learn these technical skills, but it has also taught me how to repurpose the existing material, share your work, communicate better, and most importantly, experiment and document all of it in the open so that any beginner can be reassured by the struggles that you faced and the things that you didn't understand. So my message here is for everybody who's listening in is that contribute to open science projects in any capacity that you can, or even promote the open science work that's going around you. And you don't have to be an expert to start out, especially with open science. And there is no age restriction. You don't have to have any qualifications to start out, and there is no gatekeeping. If you're willing to learn, and if you persist, you will be able to learn and contribute as you go. Okay, so why am I pushing people to contribute to open science projects? Well, because we are amidst a global challenge, that is the pandemic, and there are many brutal global challenges like climate change and misinformation. And to tackle these challenges, one has to understand the scientific literature and needs to have skills to make sense of the enormous amount of data that's being constantly generated. And the best way to learn such skills is to contribute to open science projects. And I really believe that together we can make a difference and find solutions to global challenges by working in the open. So this is the team, which is scattered across the country, and we are a diverse set of people with a shared value of doing open science. Of course, there's a long way to go for all of us, including me, but I'm extremely grateful for the OpenVirus and CV Open community, and I'm very thankful for the mentors, Dr. Gitanjali Yadav and Dr. Peter Marie-Rust, and all of my co-interns. Thank you.
Okay, so I stopped sharing. So Peter, so you could take over.
So thank you very much, Ayush and Shweta. Can people hear me?
Yes, we can.
Good. Okay. So they have both done brilliantly. And as I said, they're both technically very, very competent. And I just want to re-emphasize that. Okay, we'll go back to the presentation now. I will share my screen. you should now see my PowerPoint, and I will go back to this here, full screen, play from current slide, and we should be fine. Okay, so coming back to what we do, just to remind me, we download from the open literature. Users can put in a variety of queries and so on. We clean it, we make it semantic, so it can be linked. We annotate it with dictionaries, we analyze and display it. And you can get a result in this literally in minutes. So you can rapidly scope the literature and find out whether there's something in it for you or not. Here's our notebook again, just to emphasize, we have what GitHub calls a wiki. There's 50 pages on that, and there's literally hundreds more pages of data and text and so on. These are the dictionaries that we create. So I just wanted to emphasize each of these is a highly semantic variable object. And the key point here is synonyms in different languages, which allow you both to search non-English documents and also to render it in other languages in case people are not familiar with the English term. So here's wood in different languages. And this is a dictionary on parts of plants. Just re-emphasize that again. So where are our sources? Well, they have to be open or they have to be on our local disk. And we're particularly aiming at preprints, Europe PubMed Central, and we've talked a lot with the group in Latin America of America and others. And we're interested in this technology being available for other archives, and we'd certainly like to explore India Archive. So we'll end up with our current project, which is plants, genes, enzymes, and chemicals. Here's an example of what we can do. This is an invasive species, Lantana camara, which is a serious in India. And this is Kanishka's project, where she read 100 papers and found out which countries Lantana was mentioned in. Here's the sort of compound that plants make, carvone. It occurs in caraway. Here's the Wikidata entry for caraway. Wikidata has 100 million entries on almost everything, and it's becoming, it's going to become the global dictionary for data in science. I'm sure of that, and we're contributing our bit to it. And it does a lot with links. So this is Saga's project, where he's taking plants. Here's oranges, the enzymes they make, and the compounds that those enzymes make. If you click on this, you'll be able to see it in 3 dimensions. Let me just show that because it is fun. So here is a model of the enzyme, and you get all of that just by clicking on it. So Saga is going to lay out 5 different species: rice, mint, apple, orange, and maize. Each intern will take a different project and will come up with the gene or the genes that relate to terpene synthesis. And finally, some future development. Chaitanya has taken on Ambreen's work with machine learning. He's looking at, can he automatically pull out statements from the PDF, and he's got 95% success here. This is a confusion matrix, and this is their code for doing it. Shweta's been looking at the type of data, which people put in supplemental data. Very few people use supplemental data. What we'd like to do is to automate the collection of this, so this becomes first-class data rather than hidden away where nobody can see it. And these are the types of file that Shweta has discovered there. And again, we'd love to find people who want to use that. I believe that what we need is federated scrapers for these different archives. Ayush has been looking at that. We've been talking to one or two archives. They're really not going to be fully useful unless you can actually search all of them with one single search, not having to go into each of them and search it. So remember, save the time of the reader. They just want to click where is Lantana in the world and query 30 different preprint servers without having to know what they are. That's the type of approach that we need. So future directions, we've got 5 interns joining us in the next few days. We've also got positions for 2 interns at NIPGR, and we're looking for collaborations with people. So thanks very much to all of these groups, NIPGR, INYAS Carrier, DBT, and Wikimedia. And that's me, and this is our mascot, Amy, who represents the software. Okay, I'll hand over the screen.
Thank you so much, Peter. That was an excellent and very insightful talk. Looking into a new way of handling data, especially which is available, yet not probably fully available to the readers. So I would like to open this session for question and answers now. And probably I'll start with 1 or 2 of my own questions. So you did show us something called the make space, which I couldn't really follow. So could you please brief us a bit more about it?
Okay, Makespace, I'll go back, but I'll keep talking. Makespace is a culture of empowering people to make things. So it's based on, comes out of the hacker culture, and where is it? Here, comes out of the hacker culture, but it's the idea that rather than buy expensive things, whether it be toys, whether it be games, whether it be all sorts of artifacts, and increasingly scientific equipment, you actually make it. So there's a growing culture of making your own scientific equipment. And key tools here, they're not very big here, are 3D printers. They might take several hours to print a component because they do it by putting a thin thread of plastic around that and building it up. But you can build very complex things. You can build flow devices or sorting machines. People have built drones for agriculture, all sorts of things. And you'll find in these make spaces, people with lots and lots of different ideas. We've had a group which does air pollution. They've built their own pollution monitors. There's almost nothing you can't do. And often people have built very powerful cameras by taking mobile phones, old mobile phones, and just pulling the lenses out because the lenses are actually very high quality. So yes, Jenny's group in BioMakespace are making reagents. So she's working with Cameroon to create diagnostic reagents because, again, the commercial people have a price monopoly on many of these reagents. And often when they come out of patent, you can make them for 10% or less of the cost. Does that make sense?
Absolutely, absolutely. Wonderful. Very interesting to see the CVO project as well, and especially the kind of work that the young students and interns are doing, especially Shweta and Ayush. Ayush, I believe, is a school student, so he is phenomenal. So regarding that project, is it, I just got a bit confused. So is it like the entire open access publications need to be on a particular computer through which it needs to be accessed, or they can be available on the internet and still they can be accessed?
Very good point. So what we do is we get most of the publications from the internet, download them, and this is if you're allowed to do it. So it's not just open access if you're in a university or if somebody sent you publications. So some people I know have actually got 500,000 publications on their hard disk. Some people have got 10. And so you've got them on the hard disk, and then you run our software to search them. So you download once, and then you can search them locally. And, you know, you can, if you take 1 second per whatever, maybe you need to leave it overnight for some searches which are complex, but you know, you're not beholden on any public or private service giving you the material more than once.
Sure, thank you. So I'll hand it over to my co-chair, Dr. Kutubuddin, and maybe Kutubuddin, you can ask the next question.
Okay, thank you. Well, thank you, Professor Peter, for your wonderful talk. We enjoyed a lot, really, and how you are fighting to make the science available for the people. And I have one question here from one of the panelists from the next session, Sridhar Gautam. He asked about what is the authenticity of data that you are working on? Is it already published by peer review, or it is only from the internet repository, which is not peer reviewed?
Very good question. I will go back to the slide. I've stopped sharing, I think, haven't I? But don't worry, Europe PubMed Central is generally peer-reviewed papers after publication, but they also have preprints increasingly. So there's a big increase in preprints, and preprints can be anything from essentially the same as the published article to highly speculative and sometimes not well written. And you have to decide what it is. But I would regard preprints as, you know, a major important area in scientific publishing. In terms of data, well, we pull data out of the text. I didn't say very much about that, but many papers have got lots of tables and lots of figures, and we've developed software where you can pull data out of that, and sometimes you can get 100% conversion. So we've got a lot of data on terpenes just by downloading a table, and the rows across are what are the experimental conditions, and down here are the terpenes. So, and they've each got their percentage there, and I would believe that those are as good as they can be, and I would use them in scientific experiments. Of course, the more data you've got, the more chance you've got of checking one against another. In terms of deposited data in supplemental data, again, it's whatever the authors put up. There are very few places actually which check data other than the major data banks. So I'm a crystallographer. Crystal data is very carefully checked, both proteins and small molecules. Genes are checked, species are checked, and so on. But if you put up an experiment on, let us say, fruit fly populations or something like that, probably nobody checks it. Somebody will eyeball it, but they certainly won't run algorithms over it, at least not yet.
Okay, thank you. So, you know, I heard from many people that if it is the case of medical science and somebody, one normal general public, he sees the data and he sees a very good cure out of treatment, and if he uses that for his own purpose, for his own family, then there is a question on open data on medical sciences. So I heard this. So what is your thought on this?
So medical data is obviously more, more problematic than, let us say, data on batteries or data whatever. This is a problem that the world has to take on board. The medical Wikimedians work very hard to make sure that anything that goes into Wikipedia is actually seriously reviewed by the Wikimedians. And what they do is they only select secondary publications. So if somebody publishes a drug paper, it won't be reported in Wikimedia as accepted until they find reviews, that where more than one paper is taken into that. That's not true for various other things. So I think we can do things on plants which are less problematic than human. And then there are some subjects which to some extent review themselves. So if you're talking about algorithms, if you're talking about crystallography, there's enough internal checks in the discipline that you would wield out things which were seriously wrong.
Okay, thank you very much for your time, and we thank on behalf of INYAS also for accepting our invitation and for your wonderful talk, sharing your thoughts, and a lot of things to learn from your talk. Thank you very much, Peter, for your time.
So just probably Kutub, one very interesting question that we had from our actually one of our INYAS members, Dr. Anindita Vadra. So I would just like to touch upon that. So she is asking, if a paper is retracted, is there a way to identify its data from your database and remove it?
We don't have a database. We just have papers on your disk, right? So we deliberately don't have a database. If there is a paper in Europe PubMed Central and it is retracted, they will put up a retraction notice. Now, obviously, you might not yourself keep in touch with that, and that's a general problem of the literature. If you had a paper PDF on your disk, on your desk, you wouldn't know necessarily there was a retraction. So the problem of there is a general problem of retractions, and some journals do it well, and some are very poor about it, and some repositories are good, and some are not so good.
Okay, thank you very much, Peter. Thanks a lot. I mean, probably this is just the beginning of how things will shape up, and especially for a country like ours, where we are starting on this debate. So now I would like to request Dr. Kutub to please open up the session for the panel discussion and introduce our first speaker as well.
Okay, thank you, Nishant. So this is how we go. I want to just brief about the session, and then I would introduce the speaker for this technical session. Okay, you know, the wealth of information available from scientific literature is so rich that no researcher from any part of the globe can afford the risk of losing access to them. Data is now a form of wealth. The ongoing COVID-19 pandemic and the unprecedented pace at which we get to know the disease, develop vaccines, is a testimony to the fact that science should be accessible to all. You know, online data repositories, free access to scientific publications, rapid data sharing, and collaboration were all done that are appropriate to the urgency of this COVID crisis. And many people hope that it will change the way science is done even after the pandemic subsides. Unfortunately, till now also, accessing publications from many reputed journals comes at a high cost, a cost that many researchers and institutions across the globe cannot afford. Websites like Sci-Hub and LibGen, which provide free access to academic literature, are well known amongst the researchers, especially in the developing world. However, the recent spate of legal challenges and copyright infringement claims by big publication houses against Sci-Hub and LibGen have ignited the debate in the scientific community to discuss how we can keep science free for all. In 2018, an international consortium of funding bodies and research organizations, coalition, launched an initiative which is known as Plan S. The main principle of this Plan S is, with effect from 2021, all scholarly publications on the results from research funded by public or private grants provided by national, regional, and international research councils and funding bodies must be published in open access journals, on open access platforms, or made immediately available through open access repositories without any embargo. At present, India is not a part of this consortium, although open access sounds good, and this publication is being considered as a possible route to ensure that science is free for all. However, it is full of its own challenges, like sprouting of predatory or fake journals, high open access fees or article processing fees, and also funding support for open access fees. Since many publication houses support self-archiving and preprint repositories, many scientists think that this can be an alternative to keep science free. The theme of this year's INYAS Media Meeting is Free the Science. And this panel discussion aims at exploring the possibilities of keeping science accessible to Indian scholars and researchers. We got 5 panelists from different scientific arenas. We will listen to their unique thoughts one by one, then we will open the session for general discussion. So we have started this whole session by wonderful keynote speech. And then now we have with us Dr. Sridhar Gautam as the first speaker of this panel discussion. Dr. Gautam is a senior scientist at Indian Council of Agricultural Research, Indian Institute of Horticultural Research, Bengaluru. He is the convener for Open Access India. He has earned his PhD in plant physiology from ICAR, Indian Agricultural Research Institute, New Delhi. Apart from his research on plant physiology of agricultural and horticultural crops, he has interest in open access and open data, which made him start the Open Access India community. Open Access Journal of Medicinal and Aromatic Plants also he started with the help of his colleagues. He actively participated in the development of ICAR Open Access Policy and pronouncement of Delhi Declaration on Open Access. He is also instrumental in the establishment of Agri Archive and India Archive, preprint repositories under the Open Access India community. He is now associated with America, which I think Peter mentioned in his talk. So he is associated with America and is working for use and adoption of America XML for the journals being published by various scholarly societies in India for making enriched reading formats and for interoperability of data and information. So we are very happy to have you, Dr. Sridhar Gautam. So now the platform is yours, so you can share your screen and share your thoughts with all our audiences. Thank you.
Hope my share is visible, and thank you, INYAS, especially Kutub and Nishan for giving me this opportunity. I'm audible, right? Okay, and this talk is started by Peter sir. It's like very enlightening to many of us, and I was following him since a long time, but I didn't have an opportunity to work with him. But I was, Peter, I'm following you since long time. And coming to this open access, what Peter sir has said, and it is not only open access, it comprises many things. So open science has many facets, and it has like, it should be open. You can say it should also have the open hardware to make the things like the Pi repository, as Peter sir was saying, and many things which are comprises on this open science. So I would like to touch upon this with my topic, like creating a more enabling environment for open science. So how a environment can be created to be more open. So, but my talk will be more focused on the evaluation and the publication aspects. So the young researchers has always a dilemma. he is more interested to have open science for his benefit. He would like to have the access to all the publication happening in the world. But when it comes to his publication to be put into the internet or the web, so he has many questions in his mind. One is that where to publish, that comes because he is more evaluated to publish only in the high impact factor journals, which are at times not affordable to him because it takes a lot of time to get published. Rejection rates are more, or if there are any routes for the quicker publication, he has to pay a lot of article processing charges. So this is the environment in which he is working, but still he is producing a good quality research. So how an environment can be created for enabling more open science? So let me take you to this Jesse Call, which says the research evaluation system should be thoroughly reformed and adapted to the practices of scientific communication. The science communication has changed a lot from a print only to print online and born digital. And the copyrights are also being challenged by many people. It is, unless you transfer the copyright, it is with you. So there will not be any inheritance in sharing your literature openly unless you sign away the copyright. So this is, and the research evaluation system should be also to be adapted, and it should not only go with the the impact factor journals, where the dollar declaration comes into picture, which says that we should not go towards using the journal based metrics, but we should concentrate on the publication metrics. And the publication is one of the output, but a lot of things happen into this while making the publication, and the research outputs all should be considered in toto, and there should not be more emphasis on journal impact factor. If this kind of environment is created, and I see that any of the researcher will not have a second thought in going towards more open science or making all his research outputs in openness. Otherwise, like now, we have seen the young researchers who are not thought about their recruitments. So they are still young, they are the students. So they don't have any inhibition to share the open, so they are contributing more. But only thing is, when we are into this, getting admission, getting selected to a post or getting promotions, we have to think a lot on whether to go for open science or not. See, why is open science or not means the journal based metrics which have been taken on the first for our promotions, which they say that you should publish only in this kind of journal sets, like the UGC has come up with a whitelist which say that you should only publish in this. And in our research system, INYAS, we have one rating of a journal. So you have to publish only a journal which is rated high in 6, which again means an impact factor. And though we have a DVT DST policy, all applications will have a column for the impact factors. And recently, there was a evaluation process for all the laboratories or institutions. Even then, in that application, it has asked for the database journals which are indexed in the clavariate journals, where the journals are given the impact factor. So all things are related and going towards impact factor, and the enabling environment should not have the space for these impact factors. So then only we can progress more towards open science. That is my strong belief. And when you're talking about enabling environment, we should not only look at the journals which are published in English and which are published only in the so-called international journals. But now there is no international journals. All our journals have been taken by the international publishers. All our academies are going towards them. Like the Springer has taken over one of our oldest plant physiology publication. They have changed the title also. And I don't know what extra addition, the quality work they are going to add when it is aligned to those journals. And publishing in the journals, if you're not a member of that society, you have to pay APC charges. Again, there is a hindrance. So all our the Indian journals or the other than the English journals should be evaluated at par with those so-called international journals. Is one of the call has been declared, and maybe this we should adopt. And then when we talk about the evaluation, again, the Latin American point of view, they are also of this opinion that the quality science with the social pertinence and inclusiveness it should be considered not only just a publication impact factor, and we also believe that the scientific knowledge is a collective construction. And why now I am here working on some aspects is because my predecessors have done a lot on this. So like we read in our Google Scholar, also standing on the giants of the shoulders giant. So taking this, and we are now from Indian point of view, the STIP, the Science Technology Innovation Policy 2020, which is still under the draft, has taken these considerations, and now they are going to permit, so they should recognize the publication as a preprints for their evaluations, and they are also going to take care of the Indian journals, and the quality of the research will not be assessed mostly on the impact factors, but the social impact is they are going to consider. So hopefully that the environment is being set and created. The academies in India, the research institutions in India should in toto follow these kind of policy sets have been there. But I am still not skeptical, because we have seen the policies from the CSER, ICR, DBT, DST, which have adopted a policy on open access, but the repositories are not filled. More than 50% of the repositories are not filled with the publications. And if it is filled, it is mostly of the PDF, which the Peter sir was saying that it is blind to the people and machines. So the MLICA should be adopted, and then maybe these Indian journals should adopt those things. And saying this from the environment, but if this kind of environment is not created, what the researchers should do? They should challenge the assessment practices, and which we can see now that with the COVID pandemic, many of our researchers are gone into the publication mode of the preprints, and in the next slides we can see that the tremendous increase in the publications as a preprints, because they were not taking time to publish in a peer review, but once it is there in the preprint repository and eventually get into that publication mode, so they will buy the time of the lag and make available what their research thoughts or research results publicly available, so that the other persons can collaborate and then improve upon it. So this kind of challenge is, if not many of us have taken, so we should also go for that. And we thought of creating this kind of some awareness among our researchers in India. From the Open Access India community, we launched the India Archive journal, preprints archive. Unfortunately, there were some issues about the funds, and so it has started and it is about to close, but we could find one host who are going to host it again. So we'll be accepting the preprints publications, which still stands at 100 only now. So saying this, I would like to end, and I would like to have more interaction with the question hour. So then we can see the preprints have been taken a tremendous leap. So people are going towards it, more open science. So an enabling environment is being created, but it is to be level playing for everyone. So all the institutions should enable this, so that our researchers will not be putting a question on their mind. So I have a paper I would like to submit to MDPI, which having a 10 impact factor, but where to get the funds? So my pockets are not filled. So I need to get more authors, or I need to get a collaboration with some international author who has funds for the publication. So this kind of a thing should not be there. So the attendees or the people who are listening to this or going to watch it later should think about and create more environment for open science. I end it here. Thank you very much, Kutub and others.
Thank you very much, Dr. Sridhar Gautam. It was wonderful to try and understand how to build an appropriate environment for open science. So we will hold on to the questions for all the panel members, and we will possibly take them at the end when we will have the panel discussion. So now I move on to our next speaker, Dr. Oishik Banerjee. Dr. Oishik Banerjee currently works for the Royal Society of Chemistry UK in the Science Policy and Evidence team. He is also a part-time postdoctoral researcher in structural biology and biochemistry at Birkbeck, University of London and University College of London. Prior to this, Dr. Banerjee completed his PhD from the University of Sheffield. His MSc he finished from King's College London and a BSc from Bangalore University. He has been involved in open access and open research policy and Plan S at UK Research and Innovation Policies consultations and debates, where he has represented the views of early career researchers. So today he is going to express his views on the theme, Time to Rethink Academic Publication Model. So with this, I hand it over to Dr. Banerjee. The floor is all yours.
Hi, can everyone hear me?
Yes.
Okay, so let me just share my screen. Right, okay. So is the publication, is the presentation open?
Yes, yes.
Okay. All right, thank you. Thank you for the introduction and thank you for inviting me to the talk. So I'll just quickly go through my thoughts on open access and the problems with open access, and if we really want to address the problems that we face in the academic publication model, we might need to think bigger. So let me just start by saying that I'll be speaking in a personal capacity, and these views are my own views. And if there are certain things which are relevant to the Royal Society of Chemistry's initiatives, I will point those out and I'll speak for them. But otherwise, these will be my own views. Now, let's just start with asking why do publications charge a fee to begin with? So the subscription fee was just designed so that a journal was able to do a peer review, editing, typesetting, printing, and distributing, and sending it to libraries, and libraries can house those journals in them. But as we have shifted to a more online format of consuming these publications, this takes away many of the costs that they originally the publishers needed to spend. But still, they are charging the same amount, and a paywall still remains. The aim of open access is to accelerate the scientific research and make all publicly funded research publicly available. It's also to enable citizen science, and also the many important things that Peter mentioned earlier about letting other countries which where the diseases and problems lie to actually read about the research being done about those diseases in other countries which are richer. But still, even if you make it freely accessible, somebody still needs to pay for all the database management, the typesetting, the editorial processes, and the salaries of people who do these kind of things. So somebody needs to pay. So let us look at the two models that we have that we talk about now, which is either you pay to read, which is a traditional long surviving model, where the end users pay to read the journal, and they will definitely not pay for a journal if it's not a good quality journal. So automatically their payment determines that the journal is good quality. So journals will select papers based on quality so that the readership keeps paying for them. And this has created a sort of a hierarchical quality assurance mechanism. So you kind of have journals selecting for good quality, and then some journals charging you more because they are a good quality, or they are so good that you really crave to publish in them, And if you get into them, then you kind of feel like you've achieved something really big. So it has sort of fostered that kind of mechanism. But these are also quite expensive to get access to, because they, for many institutions, because they charge a very large subscription fees. And that's not possible for many institutions all over the world. The other model is to pay to publish, which is most of the open access models. They ask you to pay in order to publish. This obviously makes it quite complex and bureaucratic process, like we saw Peter discuss earlier. The journals themselves have no financial interest in selecting for quality. It incentivizes those publishers and also researchers who publish into them to actually focus on quantity. Because if you have the money, you can keep pushing out paper after paper, and the journal keeps accepting paper after paper because you are simply paying for it, and it has this interest in taking journals from you and then publishing it. This does give rise to predatory journals, like we know. And obviously, this is also a guaranteed revenue stream from publisher. They just don't have to do anything. The researchers will approach them with their paper and their money, and they will have to just publish it. It then ends up becoming quite expensive for researchers to actually publish. I'm not saying about all researchers, but then researchers in developing countries where funding is low for these kind of things, it can become really expensive for them. The main problem that we see with open access is the impact factor. Now, the impact factor was initially calculated by Thomson Reuters as a way by which librarians can identify which journal they should purchase, because they have very limited budget to spend. They need to focus on a particular journal. So which journal should it be? The impact factor was never intended to be used as an academic performance metric to determine whether to promote someone, to give the job to somebody, or to give funds to somebody, but it has become that. Now, open access journals try to solve one problem, but they have another issue, which is that they have a lower impact. Although this is changing slowly, but not fast enough. There is an impact on the early career researchers, future careers, if they publish in open access. And we have to think about this carefully, because many of these open access researchers are publishing in open access because their supervisor or their institute has told them that they need to publish it in open access. But what this does is that when they compete with international researchers who are not bound by these open access rules, they can't compete with them, because the international researchers who come from countries where open access is not really a thing, or where impact factors is the king, they will publish in these high impact journals and they will outcompete you. So when you apply to any international institution, you will not get the job because your research was in open access, and people look at that as a slightly less important research. It has actually become that way. And it affects early career researchers more because early career researchers and young scientists are mobile. They need to find their home institution. They need to find jobs elsewhere. So that makes them fall into this trap that whether they should publish in open access and then get outcompeted by somebody with a higher impact journal publication. So the problem here that I see is that impact factor is being used too much to measure academic performance. There is this overemphasis on impact factor, which actually needs to stop. We need to move away from using publication and where you publish as a way of measuring how good a researcher you are and for hiring, promotions, and funding decisions. Publications should be to share knowledge. It has always been to share knowledge. Whatever you find, whatever you discover, you simply put it out there to the bigger world. It is not supposed to be for publicity, for fame or fortune or for career advancement, but it has ended up becoming that. Now, the San Francisco Declaration on Research Assessment, the DORA, aims to reduce the reliance on these impact factors, like Sridhar discussed earlier. It is one of the things that lots of institutions have signed up to, and one that aims to reduce reliance on these impact factors. And the Royal Society of Chemistry is a signatory of DORA as well. I just wanted to mention that. Now, can we solve this problem of impact factor becoming such an important thing for research metrics? So instead of tinkering at the edges of open access and how to make it more open, why not try a radical solution? One of the solutions that I've thought about is why don't we use the federal publisher model or a centralized publishing model where the government or funding body who gives you money to do research also becomes a publisher. So any research that they put money into, the government puts money into, they publish it themselves in their own publication, which they make free to read anywhere. So it is going to be a free to publish and a free to read model. And anywhere in the world, people can access it and read it because it is taxpayer funded after all. The research is taxpayer funded. So why shouldn't the publication be taxpayer funded as well? So it can be peer reviewed by recipients of the funding. So whoever receives funding from the government will sign up to peer review other researchers' papers, which are going to be published. And then all research that is funded by these institutions, it will have to be mandated to be published, whether it's a positive outcome or a negative outcome, research has to be published. This model, however, risks disrupting other existing publishing model and big publishing businesses. So not everybody will be happy with this model, and it will have other issues and problems as well. The other solution we can think of is maybe we can try a Netflix model. Well, I'm just giving an example of this. It's because you can charge a very small subscription fee, a very, very tiny subscription fee, like the price of buying tea or coffee, and you pay that amount of money once a month, and you get access to all the journals. Well, there are problems with this model as well, but so this is the idea. So it will be a customer satisfaction oriented model. So if customers like researchers or students who are paying this small fee are not happy with the journals they have, then they will stop paying the fee. So automatically, whoever is this body or Netflix who's holding all these journals and asking for subscription fee will choose and weed out predatory journals from their library. It will become a bit like a library in the cloud model, like earlier, where you used to pay a small subscription fee or membership fee for a library, and you would go in the library and get access to all the books. Maybe we can try to do that, a user-friendly gateway where you go in and get all the publications that you're actually interested in. And you can petition this model to actually include more publications or things like that. And you pay a small fee in return. This fee is going to maintain this model. And also, as Netflix has showed, if large number of people end up paying this fee, then you can get enough money to actually pay significant amount to these big publication bodies to actually make their journals available on your platform. And if your platform is significant enough, like Netflix is, then the publishers will have an interest in actually signing up to be part of your model. So this is one of this. This does require a new technological system of data management to be developed. There are costs involved. And one of the companies, Pearson, who are these sort of academic textbook publishers, have shifted to these Netflix type of model now, in the UK at least, because students could never afford to buy those expensive textbooks. So they've moved to a kind of a Netflix model. So small per month subscription fee, the students get access to all their textbooks, which they update regularly. So it keeps a revenue stream coming in for Pearson constantly every month, instead of them asking people to buy their very expensive books. So in summary, we need to remember why we publish. Publication is to disseminate knowledge, to spread what we know about science. It has never been to decide how good a scientist you are, or whether to promote you or hire you. We overemphasize impact factors, and scientists should be assessed rather on skills and knowledge and competencies rather than which journal you've published. So let's try to create a better model rather than tweaking the existing model there is, because there's too many problems with open access. We should try to think bigger, not just have open access to read, but also have an equitable right to read and publish, and make it available for everybody to read and publish. Thank you.
Okay, thank you very much, Dr. Vishik. So, your talk actually, we enjoyed a lot. Your talk gave us a different direction in the ongoing discussion. And you raised many relevant questions about the present model of open access publications. And I like very much about your comment about negative result publication, that could save a lot of money and energy from other groups who also trying the same methodology for asking same question and following the same pathway. But some group in other corner of this world may have already tried thrice and they failed. So if we have some kind of publication system which also encourages us to publish negative results, we could also get benefit from them. This is wonderful insights. And yeah, the Netflix model would be wonderful if it is followed. And you said already Pearson shifted their business towards that kind of model. So it was wonderful to listen to you. And probably in our panel discussion also, we fixed a question to discuss on mostly related to your presentation. So we will discuss during that time also after we finish all the talk. So thank you. So now it's time to move to the next talk, which is scheduled to be delivered by Dr. Chandrasekhar Sharma, who is the chair of Indian National Young Academy of Science. And he is now currently working as an associate professor in the Department of Chemical Engineering, IIT Hyderabad. And let me introduce briefly him to all the audiences who do not know him, because many people are watching live in YouTube. They might not be familiar with him. So Dr. Sharma's research interests are carbon-based hierarchical materials, nature-inspired polymer functional surfaces, electrospun polymer and carbon nanofibers, and carbon ABMS. He has received several awards. So why I'm not going into details of his educational details, but just want to highlight his achievements. He has received several awards, including the NASA Young Scientist Platinum Jubilee Award in 2017, ACRB Indo-US Fellowship in 2016, IEI Young Engineer Award in 2016, DST Inspired Faculty Award, DST Young Scientist Award, INA Innovative Project Award, and then Gandhian Young Technological Innovation Award also in both the year 2014 and 2015. And also he got IIT K Excellence Award for Social Service. And recently, I must mention that he got DST Sharma Jayanti Fellowship, which is a very prestigious fellowship for a young scientist. So I'm not taking much time, so we are excited to listen to you. Chandra, over to you.
Thanks, Kutub. Let me just try to share my screen. Can you see the screen?
No, not yet.
No?
No. So I forgot to mention one. So while you try to share your screen, so according to the schedule, we actually Gitanjali, Dr. Gitanjali Yadav was scheduled to present this time, but due to her family problems, she could not join. So that's why we shifted to the next talk.
Sorry, I think there's some issue. Anyway, I think I have just one slide, so
yeah,
just, speak without the slide. Let me just put it on. So anyway, I think sorry for some technical issue with the sharing of the slide. So I think Peter has rightly put the context of this today's session on open science. And then we have two speakers who have largely covered about the academic publications, open access publications. Last talk was also giving some way forward. My talk will be primarily based on the three major factors. So why do we need the open access or open science? So what is the need for that? Second, what are the challenges and the issues when we go for open access or open science? And then what may be the way forward? So as previous speaker also mentioned that when we talk about the open science or open access, the need is realized because we need the free access of the scientific publications. And that basically underlines the limitations of current model of scientific publication, scientific publishing, because most of the time these all subscription-based journals, the institutes which are not financially well paid off, or even the countries where we identify them as low-income countries or middle-income countries, they are not having that access to that subscription because the charges are so high. So it creates an imbalance. It creates imbalance in terms of scientific publications access, and that's why there is a dire need to have to switch towards the open science or open access. At the same time, a country like India, where most of the research is being done by the government from the funding from the government funding agencies like DST, DBT, CSIR. So we all scientists do this research in our labs from the taxpayers' money. And that is where from the common point of view, from common man's point of view, there is a kind of right to information to assess the scientific publications or scientific journals we are in which we are producing our work. So that also brings the need to make it open access to all common public. And as I mentioned, this open access or open science option will also help in bridging the gap in terms of scientific culture, scientific temperament between the low income, middle income to the high income countries. Apart from that, as a PI, as a young investigator, especially when we talk about the open access publications, it also has several personal benefits. You can reach out to more people, in which you can also get more citations to your work, more accessibility of your work. And of course, that brings a lot of other matrices, which previous speakers discussed, like in terms of H-index citations and all that. So this all summarizes that we really need to go for the open science or open access. However, there are several challenges, there are several issues in going for that. And I was going through some of the comments also. Of course, there is a huge imbalance and there is a huge subscription charges, or even if you go for the open access, you have to pay a lot of article publishing, article processing fees, and which is one of the major blocking thing for the young investigators, especially from the low and middle income countries. I mean, just to mention, so in a typical project from, let's say, any government funding agency in India, you get only 50,000 as a contingency charges. Now, in that 50,000 contingency charges, you cannot really afford to go for any open access publications. So that's something which is one of the major blockages for going for the open science with the current existing model. Second is there are ethical issues, there are legal issues as well. Legal in terms of when we talk about the copyright infringements, they're in terms of providing the open access to these publications through various websites like Science, Sci-Hub, etc. Then it also brings the legal issues in doing that. Apart from that, what is more important is the ethical aspects, which basically means that when you are doing science in your lab, and then you have to pay the money for publishing it. Well, there is something called thin line between the, in our Indian system, Lakshmi and Saraswati. So now the combination of these Lakshmi and Saraswati, that's something not so well understood or well thought among the scientific community. And that also brings another challenge for going to the open science in terms of its acceptability in the scientific community. As some of the speakers mentioned earlier, well, most of these open access journals, they are having low impact factor. So of course, we can always debate on going for those journal matrices, like in terms of H-index or impact factor. But the truth is that whether you hate it or you love it, this is something which you cannot ignore in today's time, especially for the young scientist. And that is where the acceptability of open access publication is still an issue, which needs to be, for example, there is a section of researcher who do not want to go for the open science or open access just because they have to pay. It's not that they are fundamentally against of it, but not by paying it. However, there is another section of researchers which want to go for open science. And in fact, it's something very, when we publish into the Nature scientific reports or Nature communications, we highlight the Nature rather than calling it as a scientific reports. So there is a different kind of charm for such kind of open access journal, and which is basically explored by these journal various publishing houses. So I think we have several challenges and issues when we talk about the open science or open access. And again, open access publication is a very small part of the open science. And I think I was going through the comment from Nivedita that when we talk about the open science, it also includes the sharing the data, sharing the repository. And if we just leave it up to an individual researcher, I don't think we are going in the right direction, especially a young researcher who has to compete in this world internationally or even nationally. We cannot expect the young researchers to publish in the open science or to publish in the open access publication. So it has to be a kind of decision, or it has to be a kind of thought process at the top level, where we encourage the open science publications, open access publications. Some of the way forward. I think some of you are aware that Government of India is trying to negotiate with some of these publishing houses. I'm not sure what is the current status of that, but it's a kind of one nation, one subscription. And that is, I think, something a country like India, which is having such a large number of scientific community, they have the ability to negotiate with these publishing house. And if we end up with such kind of negotiations, successful negotiations, and to have a one nation, one subscription, I think that may be one way forward to go for the open science or open access. Another possibility is the sustainable model. And if we see the archive, of course, there is a lot of popularity of archive in recent times. However, if you see, I think what Dr. Banerjee was also mentioning, that who will pay for it. So I was just going through the financial model of archive. So their annual budget is of something around $2 million, $2 to $2.5 million annual. And if you count the number of publications coming out on the archive, it's around 17,000 to 18,000 per month. So if you count per year, And in that way, if you count the total, I mean, even if you just divide the charges, it comes out to be hardly $10 per preprint. But at the same time, when you go for the publishers like Nature or Springer or Elsevier, we know the charges are so high, like up to $3,000, $4,000, $5,000. So, well, one suggestion was of like federal, but I think if you go for the federal model, we are giving another control to the government, and I think that will have their own implications. So something I think we need to think a hybrid model which is neither the completely federal based or not completely based on the private publishers. Something like no society based, where there is no profit and no loss publications. And if we are able to do that, we can even encourage the open access publications with the affordable cost by the readers and by the publishers. So these may be the so that kind of a hybrid model may be in place. But again, as I mentioned, this is something to be done at the government level. Expecting it from a young PI or a group of or individual researchers, I think that will be too much to expect from them. Yeah, thank you.
Thank you so much, Chandra, for your insightful talk and to understand the kind of possibilities that we have in this area. And this is definitely very much open to debate. I really liked that how you put forward all the points that are probably the big concerns for young researchers entering into the field of academia. Not only young researchers like PhD students, but even faculty members who are probably just joining. So their first challenge is to how to get a grant. And then once you get a grant, to start spending it out on publication charges, definitely nobody is very keen on thinking about that either. So definitely, we will definitely discuss about the possible way forwards in our panel discussion. So thank you for now. We have our last speaker of the day, and after that we will move to the panel discussion. So we have Dr. Patnaik with us, who is head Department of Geology at Central University of Punjab. His research interests include understanding Earth's surface processes using cosmogenic radionuclides and the continental weathering and carbon dioxide consumption rates using major trace elements and strontium isotopes on river water and bedload sediments. Dr. Patnaik, in fact, was a summer scientific member in the 36th Indian Scientific Expedition to Antarctica during 2016 and 17. So he is one of the key members, especially when we discuss about climate changes and with the recent report from the IPCC, I think Dr. Patnaik's role is even much more important from here on, where we move ahead down the line. So he was also a National Core Committee member for the INYAS. So I now would like to hand it over to Dr. Patnaik to share his thoughts.
Thank you, Nishant, for your wonderful introduction. So I will just share my screen. Is it visible?
Yes.
Okay, thank you. And I completely agree with my other panelists. And also Dr. Chandra has nicely explained about the way forward and the challenges. And from last 2 hours, we are listening about this open science. And here I'm going to ask the one question. When we started thinking about this particular open science, and when Nishant called me and when asked about this particular panel, so first thing comes to our mind, like when we are talking about the scientific knowledge, everyone we know that it should not be content. And when we are talking about open science, actually who owns science? there are many debates and many in the literature and social media also, many times we come up with this kind of discussion. So when we look at the stakeholders, like a person who is like, as Dr. Chandra was explaining, like whether it is a young researcher or a PI, when he's getting a project or a grant, that time after lot of time in the lab, he's coming up with a paper, and one organization is supporting that particular all activity. One funding agency and government is providing funds, and when paper is prepared, when it is communicated, that time who owns the science? Like to read our own paper, we have to pay, and we are discussing those things from last 2 hours. And when we look at the ownership of that particular knowledge, and when we are using the money from the taxpayer money or public money, when we are getting a grant, that time that the knowledge is not disseminated to that society. So all this question actually comes when we talk about open science, actually who own the science. And when we talk about the open science, like my previous panelists, they were talking, it's not about only access. Open access is one aspect, and like open data, open source, the Peter's talk I was listening, and he was nicely talking about like how to develop this open data and how to access those things, even for the methodology or the data or the open notebook, and even the educational resources. So all these things is a big umbrella. Like when we look at our brochure, there also we can see that picture, and everybody we know that this open science, under this umbrella, there are many things. Scientific knowledge is like distributed in the many domains, and how open these things to the public or to the scientific community. It's not that for each of, now it looks like one kind of business, like you want to access, so you have to pay this much. So there is a hierarchy in the journal based on the journal ranking, and accordingly you have to pay for that particular paper, where we actually stand. So if you look at this open science movement, I was looking at some of the literature. That time I could see, I could gather some information. This discussion or the grassroots development of this open science, it actually initiated long back in 1990s. It actually initiated, and now it is 2021 we are discussing. And if you see the data, like this direct of open access journal, DOA, that started in 2003. And if you see the number of that OA journals, open access journal, by 2002, it was around 300 journals. And now by 2019, if you see, it's more than 12,500. It's peer-reviewed journal I am talking about. There are many other journals, mushrooming like anything further, this open access. And if you go back about the scientific journal, it's going back to 1665, when the first scientific journal, they thought that this knowledge would disseminate to the different section of the society. It should reach to the people, and it should reach to other scientific community also. But now we stand, means when we are talking about this publication and this thing, like for a researcher, it's like it's your career advancement, your assessment, all these things actually concentrate on that publication. So at this juncture, when we see that it's not that many people in the world, they are thinking about this particular open science, about how to go and what is the way forward for the open science. And already Dr. Sridhar was talking about the Plan C. When you read about the Berlin Declaration and the 10 plans in the Plan C, if you see, there are 10 plans, and there are a lot of comments about this Plan C. There are many criteria about this open access. When we are talking about this green, golden, yellow, diamond, all these things, there are many suggestions from the different part of the globe regarding the Plan C. So we don't know how many countries is going to accept, because as per the Plan C, by 2021, all this data, all this publication, it should come into this particular open access domain, and everybody should take this, everybody should access those data. And if you look at this scienceopen.com, I was looking at the scienceopen.com, the forum. They are talking about, they're discussing about the research, about the publishing and sharing the data. Some group of people, they are actually part of this scienceopen.com, this organization. But other than this, if you see each government, not only the scientific community, even government also understand about this particular aspect of the open science. And there are many government and organizations, they are supporting to create different kind of data banks, so that the government money or the fund what has been utilized for a particular scientific study, so that data should disseminate to the many different scientific communities, so that the outcome should be higher. And already Dr. Chandra was mentioning about the initiative taken by the government of India. That is very good initiative, and we are listening from the social media about this one nation, one subscription. But we have to wait for the like in which direction it is going and what is the final shape of this particular program. And if you look at this government initiative, it's I should rather appreciate that as being from a geology background, we struggle for various data. Not even for the rainwater or any kind of map is prepared by a particular government agency. Earlier, it was not open to the other scientific community. So now they have come up with some kind of database where we can actually register and we can access those data in free of cost, except for the location, which is like there is a restricted area like in border area and some area. Other than that, those data are accessible. So those kind of initiative, as already my previous panelist was telling, that it's not about individual or a single researcher will come up with some particular model. It is rather either institutional or governmental support, or government some models should be developed, and it should be supported by a institute or an organization or a government, so that we can meet the goal of this open science. And if you look at this open access, one part of this open science, open access, when if you look at these publications, I was looking at this internet, and if you see this, here you can see that closed journal, and in the open access, you have this golden and other color, gray, bronze, all these different type of these things are there. And this is the publication, and you can see the number of article in the million that has been published since 1950 to 50. You can see this black color, the gray one, that is not accessible to the others, or you have to pay, or you have to get the subscription. So that number is really high. And if you see in terms of number of articles coming, getting published in a year, and how much percentage is open access, as already other panelists already pointed out, when it comes to the evaluation or assessment of a particular person, that time the people look at differently. So people are not really ready to go for those kind of open access journal. Here, one more, when it comes to the open access, there is another thing. When I was looking at the data about the closed publication, bronze, hybrid, gold, green, in that way, if you see, look at the discipline. There is a variation in the discipline, because in social science or in other branch of science, each one is having a different perspective. And if you see for some discipline, that the number of these closed articles are much higher. And already we know, because this session is on the open access, if you look at the rate, the article APC, article processing charge, is more than 3,000, even more than that. So really it is difficult for a young PI or young researcher, or even when we are getting money from a government funding, that time it is really difficult to pay for those kind of open access journal. So what actually we required, there are before coming to this, I would like to say who is responsible for this one. Each one of us, like at a particular time, we are also sitting for the evaluation, or we are looking at a particular journal, or our mindset is now it is changing, and it's not that few people or one group is changed and then things will change. It's not like that. We have to create awareness, and we have to strongly tell others also regarding this aspect of open science. And if you look at this scientific, what we actually we want, that is timely and affordable access to scientific research. That is the main objective what we are talking about. And this publish author agreement, like we all know, when we are talking about the term and conditions, like even in other domain also, those term and conditions are so huge. Sometimes it is difficult to read and to check each point. When we talk about this publisher and author agreement, actually, when we are signing that, even in some good journal, and I'm not talking about only open access, even in other journal also, in that you are actually completely surrendering your paper with some for 6 months or 1 year, for 2 years, you don't have any rights on that particular data. After that time only you can share it. Even for teaching, only some publishers, they are allowing only 10%, 20% of the data can be utilized by the author. So those agreement, when we are talking about the agreement, in one way, immediately switching from completely this to open access or other model will be difficult, and we have to pass through a transition phase unless that model what we are thinking or we are proposing or we are going to develop, so that will take time. So in between, in the transition period also, we have to think about that particular time and how we should cope up with that. As already all panelists have discussed, better model is required, and then minimum APC. Journal ranking, already I have mentioned about this. This journal ranking should not be used for the career assessment of any scientific person. And change of ethos, like our mindset of each one of us researchers should change, and it should be accessible to the common people. That should be our main goal. Thank you. So we can have discussion during the discussion session. Thank you.
Thank you very much, Dr. Jitendra Patnaik, for sharing us the umbrella term and components of open science. And I think here you made a unique point that data sharing is equally important other than publication. So we talked about publication in the earlier discussion, but you said that data sharing is equally important for geology and weather prediction. It's not about publication, it's about data sharing and how accessible it is. So yes, it is equally important, as also mentioned by Nivedita in the chat box. So we now heard from all the panelists and what they think about open science and how it impacts researchers. And now it's time to go for an open discussion. So let me just brief the rule of this open discussion. So please turn on your video. I request all the panelists to turn on your video. And we will pose 3 questions, maybe more than that also, if the time permits, and in 3 different rounds. And for a single turn, each panelist will get 2 minutes to present his or her views on that question. And at the end of these rounds, we can take a few audience questions also. So first question I ask about about quality control in open science publishing. So, you know, the publishing system has changed and new platforms are emerging, but how do we ensure that research published in open access continues to be of high and robust quality? So I will first go to the first panelist, Dr. Sridhar Gautam.
Thank you, Kudup. Nice question. See, publication is not the end. Like when you publish in a journal, it is ended there until unless it is retracted back. So, but I would like to say that we should embrace the preprint mode, wherein you can have n number of versions, and once the preprint is there, it is not only open to the those three reviewers which the journal sends, but across all the people in the world who are looking at or working in the same area. So, and it is our responsibility also look at the published submissions in the preprint repository and should comment on it so that the researchers will improve. And that's how the quality can be ensured in the constantly by the commenting or the pointing out the mistakes, or to encourage them to submit again or rework on the methodologies or the other things. So that's how you can ensure a good quality research. If it is not this model, and if you are going for closed access only after publication, and that only those public people who could afford for subscription can only get those articles, and there will not be in a broader area where the science can be made as a public good if it is not into open.
Okay, thank you. So now you go to Dr. Vishik for your comment.
Yeah, it is a good question, because basically all the open access models at the moment, you pay an author publishing charge, which means that the journals themselves have no financial interest in selecting for quality. They can just accept whatever you publish just because you're paying for it. So one of the ways you can avoid that is to choose an open access journal which does not have a financial interest. It has other interests at heart, like there are other motives for its existence, such as the reputation of the institution or the influence that particular journal has. So in order to maintain those reputations and influence, it will definitely choose to publish your work rather than just accepting it because you're paying for it. For example, I mean, one of the examples that I can give is the Royal Society of Chemistry's journals, because they are an established institute and people look up to them. They cannot drop quality. They have to maintain quality, not because of the money you're paying, but because they already have an established name that they have to maintain. So if you choose a particular journal that has more than finance in its mind, then they will choose for quality. So they will be journals which are open access but chooses quality as well. I mean, PLUS is another example, Public Library of Science. They would accept anything that is good science, but because they have a reputation to maintain, they're not going to accept anything that you pay for. So yeah, one of the ways you can go around it is to choose a proper open access journal which has more than money in its mind, basically. But in general, open access has this problem and will continue having this problem as long as we keep having open access. We have to think bigger rather than just open access.
Yeah, thank you, Vijay, for your insight. Now I could go to Chandra, Dr. Chandra.
Well, my views on this particular question is a bit different, and I would say more practical. That we go for the open access. I think it's with the existing model of open access. I do not think that it is easy to ensure the quality of the publications. They are very valid. I mean, see, it brings a lot of subjectivity. So when, let's say, we say that we have to choose a proper open access journal, well, that itself is a big subjective thing. So I do not think that with this existing model of open access, we really can ensure the good quality of publications. So I think we need to change the model of open access, even including the archive. I mean, of course, we all are for archive, but after all, it remains. I mean, until it is really peer reviewed. Of course, you get the and I mean, after getting the suggestions, after getting the comments on archive, until unless it is really published in a peer-reviewed journal, I don't think it makes a lot of sense to the final scientific community who is the buyer of that information. So in terms of reliability and of your data, so I think it's a something something which is right now not answerable, that how we can ensure the quality in the open access journals with the current model.
Okay, so Dr. Jitendra,
Yes.
your view on this question?
Yes. In the current scenario, in the current open access, when we are looking at the open access, as we can see, there are a different type of open access. If you see, that is green or golden open access, so they have different type. So in some journal, I partly agree with Dr. Osik that in some open access journal, they do they do consider about the quality, but yes, at many open access journals are there where we cannot assure about the quality. But yeah, definitely if we go or we can change towards this repository or the archive model, there we can take this open review, open peer review, like it is a part of the open science. If the scientific community, they are really worried about the data, because when I require a data, I want its quality. But when it comes to the review, that time also I should put in the same temperament, I should review that article and I should put the comment. If we can make such kind of archive and preprint archive, and when we go for this open peer review system, that time it's my responsibility also that I should review it thoroughly and I put the comment. But yes, at the same time, if we are going by this model, who will check it? Who will cross check that those peer reviewed or those suggestions were incorporated in that paper or not? For example, when we are looking at the social media, one post is coming, we are seeing hundreds of comments. Okay, so there you are not spending much time, but when it comes to the such kind of model, if we are putting the archives are there and there is a open peer review system, and if somebody is getting some 100 comment or 100 these things, so that time whether those comments were taken care by the author or not, and whether during the publication those comments are it will be published or it will be available to the readers. So if that can be possible, then yes, that model, in that model, this open peer review plus the comments what that paper has got from the peer review, that is also associated with that as a supplementary data, then there is I think in that way we can a little bit we can thought about the quality. Because here my reservation is like even in some journal also, even in the higher impact factor, there sometime we feel that the review is not proper, because we see some paper which is not worth to be published in that particular journal. That is my submission. Thank you.
Yes, you are absolutely right. So thank you for being on time, all the speakers, and also we request you for the next question also be on time. So next question will be handled by Nishant, Dr. Nishant.
For the previous answers. So the next question is regarding article processing fees and open access charges. So no matter how much we keep debating, I think we have seen an environment where open access publications are increasing and possibly will be increasing. Yet this has been touched upon during the discussions that open access charges are world. This is definitely a discouraging factor. So do we have a better model that will encourage researchers to go for open access? And I know we have touched upon a few of the points. So I would like to start with Dr. Oishik Banerjee, because he discussed about the federal system. First one is whether there will be a conflict of interest to begin. Over to you, Oishik.
Yeah, so it is a difficult point, because the article processing, somebody has to pay to get something out there. So it either has to be the reader or the researcher who's putting paper out there. So one of the ways that things work here in the UK now is that the university pays to publish in open access journals. So if you are a researcher working for a university, the library funds that the university has to maintain its library, it uses that fund to pay for open access. So each author or each PI or somebody who's publishing gets money from the institute itself to publish. But that is not, that system won't work everywhere. As one of the ways I mentioned is that if you have a federal model, so the funding body or the government who's paying for research, ultimately is all paid by taxpayers mostly, becomes the publishing body itself, and then anything that they fund, they accept the outcome of that research, whether it's positive or negative, and then publish it in their own repository, and that stays forever. So in that way, you can have a free to publish model as well. So it's not just free to read, but it does require a sort of a big kind of a shift in thinking. You don't always have to pay these expensive journals to just publish research, which was paid by the taxpayer originally. So they are just coming in from outside and kind of making a profit because we are used to this system. So if we can have a federal publishing model, then this problem doesn't arrive at all. So you don't have to pay anything for publications. And it also removes the concept of impact factor and research metrics as well, because everybody's research is there to read for good.
Thank you. Thank you, Dr. Banerjee. So Chandra, your thoughts on this?
Yeah, thanks for this very important question. So I think as we all agree that the current APC is too high for especially for the young researchers and for the researchers from low income and middle income countries like India. So I think my suggestion, as I pointed out in my talk, is that there are two possibilities. One is the hybrid model in which the authors also pay and the subscriber or the readers also pay. For example, let's say if my institute is having a subscription of a particular journal, then since my institute is paying for reading it, and then as an author of that institute, I should be having some assumption in the APC. So that is one way of doing it, by sharing the expenses. Secondly, if we see about the APC and especially the very high charges, so definitely it is for the business. It is not for the science, because as far as I mentioned during my talk, data that if we talk about the real expenses on the archive, it comes out to be hardly $10 per paper, while we are paying something around $3,000 to $4,000 per paper. So I think if we can have some non-profitable societies who can be the leader of the science publications, where they meet their expenses by the publication charges and as well as the subscription charges, I think we can address this situation of high APC. So that's my take on that.
Thank you, Chandra. So Jitendra, any comments on this question?
Yeah, one thing I couldn't understand why there is a so much of variation. If you see, maybe it is making some class that the publishing charge. If you see open access journal charge, it can vary from $100 to $3,000, $4,000 like that. Here, like what actually controls that? What makes that journal? We know the impact factor is high, that the publishing APC charge is high. So if we talk about how much they actually required for publishing and this thing, if like I agree with Chandra, it's not for the science, it's completely for the business purpose. And when we are talking about these two things are actually linked, this impact factor and the quality or the class, what we are in a societal term, we are talking about the class. Similarly, here also there is a class that if you want to publish in this journal, yes, your paper should be in that quality, plus in addition to that you should have money. So both thing is going. So it is not it is really difficult to have that much, I mean, we have difficult to pay that much high APC charge. So there should be some regulatory, some body, it should actually look into this particular APC charge. Otherwise, when we move to the different model, that is completely different scenario. But in the existing model, there should be some controlling, some regulatory thing we can actually talk to these publishers, the giant publishers. That's all from my side.
Thank you, Jitendra. And so, Dr. Sridhar Gautam, your take on this?
Yeah, open access, when we mean it is not expensive. It was the free to read, free to publish everything. But the section of the publishers who are into this like business models have taken up, and then the APCs have come into the picture. See, the reviewers doesn't get any funds, I mean, it's a remuneration for reviewer, and we have the free and open source softwares, not only for journal hosting, but for making into other formats like the XML, HTMLs, and all the formats can be done with the freely available software. Others are not paid back to them for these articles. So why the question of this kind of a business model? Just because we look for the more esteem, like the class which the Patnaik was saying, that you travel in a higher class, so you pay more for it. So okay, let them go and for it, but the affordable class people should be considered, and the what I was talking about, the environment which we should create, we should not see differential between those people who are publishing in a high class or esteemed journals and who's not publishing in a with other normal journals. And then the societies like us in IHR Bangalore, we have a society which we are giving all quality control, everything we are doing it. All our reviewers are giving a good reviews to the papers, and we don't charge for it. And we host in the open journal systems. And we are now talking to the America model and then making all our different formats. So there is not much of commercial activity into that. And the APCs which we are talking is exorbitant. That's what they say. I mean, we can see it like $1,000, which is not affordable. And why people are going towards it is because there is an impact factor. If you take away, let's see how that business goes into the picture. So this is my take, that open access should be non-commercial.
Okay, thank you very much. Thanks a lot. So thanks for sticking to the time as well. I hand it over to Kutub to wrap up the session. I am sure there are lots of questions, and it's a very open debate, and probably this is just the beginning. We need to move ahead from here on. So thank you very much. Kutub, over to you.
Yeah. Okay, thank you, Nishant, and all the panelists. We wish we could have more time to discuss on this matter. This is so engrossing, and getting your viewpoints on these, but we cannot continue like this because we have a time limit also. So we have to end here for today's session. And I hand over happily to Dr. Rajendra for wrapping up this session. Dr. Rajendra, please.
Yeah, hi Kutub, can you hear me?
Yeah.
Okay. So let me thank both the session chairs, Kutub and Nishant, for really nicely organizing this session. It was really fruitful discussion, and I'm sure it is very helpful to all young researchers in particular. Let me thank all panelists for their views on this very important topic, and nice discussion towards the end. And of course, we all should thank our keynote speaker, Peter, who has spent a lot of time and, for his really insightful thought on this topic. And I'm sure that this will benefit all of us. And as Kutub in the end nicely mentioned, that we, of course, need more time to discuss on this point and the way forward. So of course this session opens this discussion, and I'm sure that we will have more sessions in future, discussion on different platforms, and then come up with solution, or at least to help young researchers in this regard. Okay. So with this, I thank all of you for attending this session and for active participation from all the INYAS members and all invited guests, particularly also our alumni, Dr. Mahesh Kumar, and there are many of our alumni members also in this session. With this, let's close this session, and I would like to request all the members to join for another exciting technical session tomorrow morning. So the session will start at 10 o'clock, and I request all of you to please join at least 5 to 10 minutes before. So let's join by 9:50, so that if there are any small technical problems, we can resolve before the session starts. So with this, I thank you all, and we can disperse for this session today. Thank you all. Thank you so much. Bye bye.
Thank you, Professor Peter, Dr. Oishik, Dr. Sridhar, and Dr. Chandra for your time in discussing this matter. Thank you, Nishant, also. Okay, thank you all.
Thanks a lot.
So let's meet tomorrow morning again.
Yeah,
Bye.
sure. Thank you.